This video is an introduction to the design process that structured the comprehensive or integrative design studio at LSU School of Architecture. The goal of this approach is to trade the designer's fixation of the architectural object for one of an adaptive assembly. For this course, independent design investigations into 3 adaptive assemblies, a retaining wall, a porous wall, and a green roof assembly, are challenged to respond to distinct aspects of the project. By developing these independent assemblies first, the designer shifts their focus from a preconceived formal answer to a direct design response by the materials and their assemblies to the project's environmental, economic, and social factors. As prioritization of site, programmatic, environmental, and life safety concerns weigh against each other, a level of abstract thinking and self-critique is required in the deployment of the adaptive assemblies. This internal struggle by the designer is used to question BIM's linear path of optimization and coordination. The first 2 weeks of the semester were spent quickly identifying and cataloging key factors of the project. The project marries the Imagined Plank Road redevelopment proposal by Build Baton Rouge with the ACSA's Steel Design Urban Food Hub competition brief. Called key factors, the class begins their inductive analysis of the project by researching compelling facts about the site and program. The precedent analysis is broken into 2 distinct areas: student diagram, passive design strategies, resourced from the Living Building Challenge 2030 palette. And separately, they draw steel connection details to form a stronger relationship between the desired atmospheric qualities and the required construction details. The porous wall adaptive assemblies must filter a selection of identified key factors, just as the retaining wall must be designed to hold others. By identifying the desired human engagement of the green roof assembly, an intensive or extensive system is selected. These adaptive assemblies are matured for several weeks as they attempt to capture or answer as much of the program as possible. The students move to programming with adjacencies and siting strategies. Through multiple schemes, formal compositions attempt to identify each of the adaptive assemblies responding to site opportunities. Site strategies move to massing and focus on the development of structural ordering systems. Once a final scheme is identified, the adaptive assemblies are deployed and axonometric studies are used to discuss further integration of structural environmental controls and life safety concerns. As the ACSA competition requires 4 boards, the designers focus on the communication of 4 compelling reasons why the proposal is successful. This architectural argument exercise helps to identify, prioritize, and communicate 4 strengths of the proposal. For each board, the designer ties the needs of a unique user to a specific architectural design decision within one of the adaptive assemblies. Each board is challenged to combine technical documentation, experiential drawings, diagramming, and research data to frame why the proposal is necessary. In addition, each board nests additional systems-focused research and design decisions to further communicate the depth of the design proposal. Once the primary argument is seated in each board, the designer is able to identify and prioritize their time and effort for the remainder of the semester. For the past 2 years, using this design process, students from this comprehensive studio have been awarded first place in ACS's Built to Last and Designing Healthy Places concrete competitions. The ACSA competition requires a 300-word essay, which you will hear the designers narrate over their slides. Thank you for your time.